My name is Rick Haskell, and today we're continuing to take a look at labor market marginality. Specifically, we're looking at the marginal product of labor as it relates to this sandwich shop example that we dealt with in the previous segment. So we're going to use those same values, and we're going to use the same assumptions. Recall that we assumed in our example here that the capital employed in our little sandwich shop, our tiny little sandwich shop here to the right, is fixed, which also then means our technology is fixed. And technology in this case isn't just about equipment and software and such. It would have to do with the distribution of our labor, our production line, how we've organized our labor here. We've assumed that the price of our sandwiches at output is $5 per sandwich, and that our wage is constant for each of our employees at $10 per unit, or let's say that's $10 an hour in this case. And we noticed that as we had one worker could do 15 units of sandwiches, adding a second worker could add 20 units to us, so a total of 35. We then had a third worker that we added, and that added a 10 to us, so not quite what we might have hoped for, and that was because our sandwich shop started to get a little bit crowded over here. It was a little bit difficult with our given technology, our given organization, to be as productive as we should have been. We maybe could have used a change in technology here, but we just didn't do that. In this example, we're thinking of everything as being fixed, of course. And then as we went from 3 to 4 workers, we found an even smaller increase in the output. We only had an output of 5. And then from 4 to 5 workers, it became so congested, we had no increased output at all. So each labor unit was producing less for us. And then frankly, as we went from 5 to 6, we had a decline in output. So we became so crowded that we couldn't even produce what we'd been producing before. Well, we indicated that we can measure this by measuring the marginal product of labor. And the marginal product of labor is simply some change in the quantity output divided by some change in the labor units. So the change in the output divided by the change in the input. And we can then consider what that's given us. So let's try to fill out a graph here, or a table, and then a graph, helping us see what our marginal product of labor is at each of these points. Well, recall that we went from 0 units of labor to where we had 0 quantity to 1 unit of labor and 15 quantity. So we had a 15 unit increase. That meant that our marginal product of labor was 15. And then as we had another 1 unit of increase, we had an increase of 20 units of output. So our change in quantity divided by change in units, it was 20 divided by 1, or 20. This is simple for us. And then we then see that one more unit gave us 10 units of output increase. And then another unit of labor gave us 5 units of increase, 5 more sandwiches. But then another unit of labor really didn't give us anything more. We got to a point where we were so crowded back here in our little sandwich shop, we needed more space, we needed to bust out the walls, or we needed to add something to our counter, or we could have just learned a lesson from technology and started a production line. But we didn't do any of that. This is a very simple little shop. And so we had a 0 increase, so we had a 0 marginal product of labor, and then we got to where our increase in units of labor actually led to a decrease in output, so we had a -5. Well, what we're trying to get to here is a point at which we have the greatest productivity, and we've put out as many units as we can, and we've still made some money doing this. And we're going to look at this through these segments. But now let's take a look at how we might graph this. What might this look like? Well, here we're going to be looking at our basic XY coordinate again, as we have before. But now we're going to look at marginal product of labor on the y-axis and labor units on the x-axis. And here, with 0 and 0, we're nowhere, of course, but at 1 unit of labor, we then saw that we had marginal product of labor of 15. So let's give ourselves some hashes here. And we'll say 5, 10, 15, 20, 25, 30, and that's more than we're going to need. So 1 unit of labor brought us here to this point. Our second unit of labor took us to a marginal product of labor of 20. So now we're here. Our third unit of labor brought us then to 10, so that's a pretty dramatic decrease. Our fourth unit of labor, let's see, that was 10. Our fourth unit of labor brought us to 5. Our fifth unit of labor brought us to 0. So let's change the pen color so we can actually see that. And then finally, our sixth unit of labor took us into negative space, and so let's say that this is -5, and so actually took us down here. What we see is a curve develop here, and this curve has increased to the point that we actually have our highest marginal product of labor, and then begins to decline and comes down even into negative territory. Well, that's a terrible looking line, so let's see if we can't make that a little bit better. Something's going to look kind of like that. So we're decreasing here. In fact, we've even gone into negative territory. And this would be consistent with what we would think of in terms of marginality of inputs to production. As we begin to use the capital in our operation, whether that's technology and or physical capital, we increase to a point where we're beginning to use our environment efficiently. And then from that point, we begin to decline until we get to a point of 0 marginal product of whatever the input is. In this case, that input is labor, and we decline beyond that. We went down into negative territory here. We don't want to be in negative territory. It doesn't help us at all. So this is a graphic representation and a table representation of the marginal product of labor through its equation and through our little sandwich shop experience.